Hello viewers, in this video we'll be looking at a quick review of P3 and P4. So P3 is about integer exponents and scientific notations. So the first thing to discuss here, it's what we call the exponentiation, or call it the exponential notation. And what is this? This says that if A is any real number and n is a positive integer, okay, then the nth power of A is given by what? A to power n is nothing but what? A times A times A, how many times? And this is just like n factors. So this is what we mean by the exponential notation. So for example, if you have, let's say A is 1 over 2, which is A is any real number. So for example, if you say 1 over 2 to power 3, this is simply saying that what? 1 over 2 multiplied by 1 over 2 multiplied by 1 over 2, which is simply 1 over 8. Or let's use integers. If you say 2 to power 3, it's going to be 2 times what? 2 times 2 times 2, which is just 8. All right. So here, just to note that if we have something like this, let's say you have minus 2 to power 4, this is saying minus 2 multiplied by minus 2 multiplied by minus 2 multiplied by minus 2, which will give us what? 16, because you have minus, minus will cancel minus, minus will also cancel minus. So we have a positive number. But if you have something like minus 2 to power 4, you can see here the exponent, which is 4, is what? It's just the exponent of 2, not minus 2. So this, in this case, we have a minus outside. Then you have 2 to power 4. This is the same thing as this. So this will be, the minus will still remain outside. So you have 2 multiplied by 2 multiplied by 2 in 4 places. And this should give us what? Minus 16. Is that okay? So this is simply what we talk about, the exponentiation. And now the number A in general, when we have something like this, 8 or n, this number is what we call the base, and this is what we call the exponent, right? So take note of this. And that is why we call it what? We call it integer exponent, is because that this n is always an integer in this case. All right. So now there are some properties that we'll need to talk about in these parts. So we call them the properties of exponentiation, or we call the laws of exponents. So just a brief laws of exponents. So there are about, let's say, close to 8 laws of exponents. So let's just have briefly. Anytime you multiply exponents, as long as the bases are the same, is the same thing as adding the powers. And if we divide, then is the same thing as subtracting the powers. And also we know that what another one is that if you have a to power 0, this is always equals to what? This is equals to 1. And here, provided that a is not equals to what? A is not equals to 0. Then we have, if you have a to power m over a to power, I think we have this one already. Let's say you have ab all to power n. This is simply a to power n and b to power n. And also if we have a over b all to power n, this we can write as what? A to power n over b to power n. And let's say we have another important one, a over b to minus n. This we can write as b over a all to power n. So all these are exponent are properties or laws of exponent that we need to remember. Just to Now we're not going to prove all of this, so let's go and discuss something else before we take some exercises on this P3. Okay, now let's talk about scientific notation. So scientific notation is actually used to express very large numbers and or a very small number. So for example, any number you can write in the form of b times 10 to power n, where b is between 1 and 10. So b is less than 10 but greater than 1. And what? N is an integer. So any number you can write in this form, we say that number is in what? In scientific notation. So please take note here that b is what? Here, b is what? Is a real number, right? So b is a real number. That is the first condition. B is between 1 and 10. B can be 1, but it should be less than 10. And n is an integer. For example, if you have, let's say, this is 5 million, we can write it as what? 5 times 10 raised to power 6. So you see this number, very large. This is what we call, this is in decimal notation. But this is now in what? In scientific notation. So you see, whenever we move, how do we move? You can see here, we can say like maybe the decimal point is here. So we want to move it. So we'll move it 1, 2, 3, 4, 5, 6. So we moved it 6 times to here. So we move it from where? From, let's say, from my right to the left. So this is like going this way. So when you move this way, you move your decimal point this way, the power will be what? Your n will be positive. But if you move it the other way, your n will be negative. For example, let's say you have, this is a very small number, 1, 2, 3, 4, 5. And let's say we have it this. Now, to write this in standard notation, you see that you are in scientific notation. we're going to move how? We're going to move this way. So you're going to move your decimal point this way. So when you move now from left to right, so it means definitely your what? The n is going to be a negative integer. So for example, we move 1, 2, 3, 4, 5. Now if you stop here, it's going to be 0 point what? Zero point 0.5 times 10 raised to power minus 5, right? Because we moved 1, 2, 3, 4, 5. But if you leave it like this, it's not really in a scientific notation yet, because for scientific notation, look at where we want the b to be. In this case, this is our b, but b is what? Is less than 1. So it means we need to go one more. So we'll go one more here to this point. So this becomes 5, and this will be times 10 raised to power minus 6. So when we go from right to left, this is from right to left, yeah? Or let me do it this way. This is from right here, and you're going to left. So you see that we will have a positive exponent. And when you go from left to right, you're going to have a negative exponent. Okay, so these are the two types. We have scientific notation and we have a decimal notation. So don't forget that this number is in decimal notation, NN, but this now is in scientific notation. So take note of this. So just to, if you have a number, numbers like maybe 50, 0.35, all these numbers are in what? Are in domestic decimal notation. So we can easily convert. For example, if you have 5, you can just write 5 times 10 raised to power what? 10 raised to power 0, right? This makes it a standard, or what we call scientific notation. All right, so let's take this example quickly. This example is for P3. P3, this is integer exponent. We have this, we want to simplify. So we need to write this as this, then we find what is A and B and we add. So here, the first thing we can do is to what? Is to get rid of this negative. And we can do by what? Just switching. So this becomes x squared. The denominator becomes the numerator. And here you have 3. And which property have we used? We saw the law of exponent. We saw that if you have a over b to power minus n, this it's simply b over a to power n. Now we can clear inside before we can say, you can see this x can go with this x. So here we have just one x. And this is inside, you have y to power 3 here. This is minus 2 in the denominator. So it goes up to become plus 2. So you have this. And for z, you have minus 4, also plus 3. So what have we used? We've used the fact that if you have a to power m over what? A to power n, you can write it as m minus n, right? And if it is minus here, it goes up to become positive. Or if you have am minus n, this is the same thing as am plus n. All right, so now let's simplify this. So this becomes x, and this is y to power 5, and this is z to power, and this will be minus 1, right? And all to power 3. So now we can take the 3 inside, so that we have x to power 3. So 1 times 3, then this will be y. 5 times 3, 15. And this will be also z to power minus 3. Okay? So we need to compare this with this one. So if you look at that, here there is a minus. So let's rewrite this. So we can write this as minus 3. Then we have y to power b, y to power 15. So let's leave it now. And z to power minus 3. So it sees that what? Our a is going to be minus 3, right? Then b is still 15. And c is going to be 3. Since there is minus here, there is minus. So you see that if you do a plus b plus c, this will be minus 3 plus 15 plus a 3. And this will just be 15. So we have this one. All right. Next is this one as well. So for this, we can just go directly. This is product. So this now becomes, we can write this as 3 cubed x cubed, then y to power what? Minus 6. Then everything multiplied by here. This we can first of all take it down. This we can write it as 1 over 6x minus 2 y minus 3 all squared. Yeah, just to get rid of the power, right? Because we know that if you have a minus n is the same thing as 1 over what? An. It's also one of the laws of exponent. So here, this becomes 27 x to power 3. And this one, we can even write it as this one, y to power 6 in the denominator. And here, we can write this as, now this we can write it as 6 square x to power minus 4. And here we can write it as y to power minus 6. So please don't forget, here you can see we have this one to power 2, right? So the mistake student make is to say this is minus 3 then square it. No, this is just minus 3 times 2. And the same here. So the property we're using here is that if you have x to power a times b, it's just x to power what? A times b. So the power becomes a times b. So when you have y to power minus 3 over 2, it's just y to power minus 3 times 2, which is minus 6. So don't do this mistake. Don't say it is y to power 9. You said minus 3 squared. No. Okay, so now let's rearrange. This is 27x to power 3, y to power 6 times. You can see here, this is y to power minus 6. It can go up, so that you have y. And even the x to power minus 4 can also go up to become just x to power 4. Then in the denominator, you're just left with what? With 36. So now we can cancel out easily. This will go with this one. And here we can, okay, we can say we can divide by what? By 3, right? So here we can divide by 3. So we say here, what is 3 here? 3 into 27, we've got 9. 3 here is what? Is 1. And 3 here is 2. So for now, we have 9x to power 7 divided by 12. And we can divide by 3 again. 3 here, 3. 3 here, 4. So we have 3x to power 7 divided by 4. All right. So now let's take questions on scientific notation. If you have m to be this 0.00003, and you have n to be this large number, so you have a small number and you have a large number, you want to find the product in scientific notation. So let's start with m. So for m, to write it in scientific notation now, you see that we are moving from where? We're moving from left to right. So 1, 2, 3, 4, 5, 6, 7, 8, then 9. So this is 3 times 10 raised to power minus 9. Because we move from left to right, so the power is minus. Then this is n. Okay, let's write n now in scientific notation. And now we have to move from where? From right to left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now this is 11. If we leave it as 11, then this will be 23 times 10 raised to power positive 11. But you see that this is not in what? In scientific notation yet. Now, we can write it in scientific notation to move it one more, so which is this one, 2.3. So in scientific notation, it's going to be 2.3 times 10 raised to power 12. Yes, because you see this number is bigger than 10. All right, but now this is not the final answer, so it's okay to even leave it this way, but we will get back to it. So now let's look for mn. This is just 3 times 10 raised to power minus 9. Then you're multiplying this with what? With 23 times 10 raised to power 11. Don't worry about this 23. We can still use it now because we just need the final answer to be in scientific notation. So here, what we can do is this one. If you look at this, 3 times 20, 23 will give us what? 69 times, then the power here, this will be minus 9 plus 11. So this is 69 times 10 raised to power. And now what are we going to get here? This will give us what? This will give us 2. 2, right? Okay. But one thing here is that if we look at this number, it's not in scientific notation yet because here we have a 69. And don't forget, we said if you have a scientific notation, the b has to be between 1 and what? And 10. So we need to rewrite this one. This is 69. You can write 69 as what? In standard form, to write 69, just assume that the 0 is what? Is here, right? So the point is here, so you have to move it 1. So this will become 6.9. So you have to move from right to left. So this becomes 6.9. And since you are moving from right to left, you know the power will be what? Will be positive. So this is times 10 raised to power 1. And now this is times 10 raised to power 2. So this is just going to be 6.9. And this is 1 and this is 2. So this is power 1 plus 2. So you have 6.9 times 10 raised to power 3. Okay. And we have this one. Then finally here, okay, we still have 2 more, right? So for this one, what can we do? The same way, we're looking for a over b in this case. So what is a? A now is what? A is a small number, so we go from left to right. 1, 2, 3, then 4, right? So this is 4 times 10 raised to power minus 4. Because we move from left to right, so the index should be minus. And now we divide by, this one is already in standard form, so which is 1.6 times 10 raised to power 11. Now to divide here, what we can do, it's this. You can rewrite this if you don't want to deal with decimal. We can write this as first. This you can change it to what? This is 1.6, right? 1.6, you you can write it as what? 16 times 10 raised to the power minus 1. It means you move the point from where? From left to right. So you go forward. So it becomes, the power become minus, then times 10 raised to the power 11. So anytime you move forward, you move the decimal point to the right, you know your power should be negative. So here it is 1.6. Now I change it to 16. It means we moved it to the right. So that is why we have minus 1. Now, why did we have to do this? It's so that you'll avoid the decimal first. So this is 16 times now minus 1 in 11. So this is just what? This is just 10. Okay. So here you can see that 4 here will go with this. So you have 1 and here will be 4. So in the numerator, we just have 1 times 10 raised to power minus 4. And don't forget that the power here now is 10. So this 10 can go up. So it becomes minus 10. Then here you just have 4, right? Okay. So you have 1 divided by 4. 1 divided by 4, we know it's just 0. What? 25. And this is times 10 raised to power minus what? Minus 14. Yes. Okay. So if you look at this number now, this number is 0.25. It's not in the range that we want. We want our B to be between 1 and what? And 10 open. So it means we need to make it bigger. Here is too small. So to make this number bigger, you have to move the point from here to the front, right? You have to go to the right. So we need to go to the right how many times? Just one time. So that it becomes 2.5 times, since we move to the forward one times, it just be times 10 raised to the power minus 1. Now, if you go 2 times, it will be 25 times 10 raised to the power minus 2. But we don't go to 25 will be more than 10. So we stop here. And now this is times 10 raised to the power minus 14. So this is just 2.5 times minus 1 minus 14 will give us minus 15. And we're done. Okay, so now let's look at this one. So for this, we can decide to maybe go directly, and we'll be fine, right? So here directly you can see, you can just do your cancellation. This is 2.3, this is 6.9. So if you look carefully, you see that this actually 2.3 can go into a 6.9. How many times? This is just 3, because 2.3 times 3, you can see it is what? 6.9. So you can still do it directly. So here is just what? It's just 3, right? And now this is 2.0, and this is what? 4.2. And if you look at here, this is nothing but what? Just 2.1, right? So let me write it again. So we just have 2.1 times 3 times, this is 10 to the power minus 7. These are the powers. This is minus 7 and this is plus. So I can put it as plus 5. Over here, nothing is left again. So you just have 10 to the power 3. And this is minus what? Minus 9. So the powers. And now 2.1 times 3 is just going to be 6.3 times, this is 10 to the power minus what? Minus 2. And here in the denominator, we have 10 to the power minus, so let's see here. Here, what do we have? We have minus 7 plus 5, which is minus 2. And here we have 3, yes, minus this. So this will be minus 6 here, right? So this becomes 6.3 times 10 raised to the power minus 2 plus 6, You can take this up to become positive. And now this will be 6.3 times 10 raised to power. And here will be 4, right? Okay. Now, so this is saying that the answer is 6.3 times 10 raised to power 4. Okay. Now, let's look at this carefully. Mm, Okay, we say 2.3 and this is 3. Yes. And this is 2.1. So 2.1 times this, we have this. Minus 7 plus 5. And this is minus 2, correct? And this is 3 minus 9 minus 6. And this goes up to become a 4. And we're fine. So the answer to this problem, it's what? It's not A, but B. Okay. All right. So these are some few examples for P3. So thank you for watching. In the next video, we'll present P4, just to avoid this video from being too long. So next video, it will be section P4. Thank you for watching.